comet impact sparked a massive change on Earth 13,000 years ago. We know what happened 13,000 years ago, and you'll see a map of the fragments of a comet that hit us around that time. They're finding new fragments all the time, not only in the northern hemisphere that caused a wide range of fire, and they found a layer of ash at that time, but also in the southern hemisphere. They call that the Younger Dryas event. So imagine being a hunter-gatherer nearly 13,000 years ago. You're minding your own business, gathering berries, hunting wild animals, when suddenly a giant ball of fire appears in the sky. It explodes with a deafening roar, sending shockwaves around towards the ground and flattening trees and homes. The new research suggests this is how the first seeds of agriculture were planted in Syria, a necessary adaptation to improve the community's chances of survival. After a comet's fragments slammed into Earth's atmosphere, the climate changed dramatically, with the plants and animals they relied on disappearing. The global team presented their case after analyzing sediment layers from Neolithic site in Abu Huraira, which was excavated in the 1970s before being submerged under Lake Assad by the construction of the Euphrates Dam. Abu Huraira is well known as the site with the earliest evidence of a shift from hunter-gatherer to farming. The group contributed their 4 peer-review papers to the study of the Younger Dryas impact hypothesis. This substantially disputed hypothesis proposes that a cosmic impact caused the Younger Dryas YD period, a rather sudden, severe, and lengthy interruption to the warming of Earth's climate. And they said, we present substantial new quantitative evidence and interpretations supporting the hypothesis that comet fragments triggered near global shifts in climate 12,800 years ago, and one airburst destroyed the Abu Huraira village, the authors write. The sediment layers revealed many factors, including types of plants collected in warmer, humid days before the Younger Dryas climate change and in the colder, drier days after that. These data include changes in building architecture, diet, the early stages of persistent cultivation of domestic-type grains and legumes, the team says, and the initial penning of livestock, marking the beginning of sustained agriculture and animal domestication. Archaeologist Andrew Moore from the Rochester Institute of Technology and team's comprehensive analysis also identified shock-fractured quartz grains, which are consistent with impact and evidence of a massive firestorm. Shocked quartz is well known and is probably the most robust proxy for a cosmic impact, says earth scientist James Kennett of University of California, Santa Barbara. In the papers, we characterize that the morphologies of these shock fractures in these lower pressure events. Their initial study confirmed low shock fractures in the quartz rocks at Meteor Crater, created by Barringer meteorite impact. And importantly, similar fractures occur in quartz exposed to nuclear explosions in the air, even if no impact crater forms. This has big implications, suggesting an asteroid or comet breaking apart close enough to Earth's surface could also cause these fractures via shock waves across the world. For the first time, adds Kennett, we propose that shock metamorphism in quartz grains exposed to an atomic detonation is essentially the same as during a low altitude, lower pressure cosmic airburst. The second study is the first to identify shock fractured quartz in the Abu Huraira sediment layer from the boundary, the beginning of the Younger Dryas period. Detailed analysis shows some quartz grains in the layer are similar to those found in nuclear explosions and Meteor Crater. We wanted to compare it with what we have in the shock fractured quartz in the Younger Dryas boundary, says Kennett, to see if there was any comparison or similarity between what we see in the Trinity atomic test site and other atomic bomb explosions. Most of these quartz grains have been exposed to temperatures at least 1,713 degrees Celsius, which is 3,115 degrees Fahrenheit, which is the melting point of quartz, and most likely even higher than its boiling point of 2,200 degrees centigrade. Extremely high temperatures and pressures lead to fracturing and melting of quartz grains and introduction of molten silica into fractures. When this non-crystalline silica is found in fractured rock, it's a clear sign of an impact as opposed to slow tectonic movement. The third study found tiny diamonds, special crystals, and small balls made of silica and iron in the Younger Dryas boundary layer sediment. Some of these substances could only have formed under higher temperature or pressure conditions than any human technology could produce at the time. One substance, tiny spherules called melt glass, makes up about 1.6% of the sediment and was discovered on tools, bones, and clay walls, suggesting the impact really disturbed life in the village. Pieces of melt glass even have detailed imprints of plants. And notably, the team did not find similar material in thousands of years of human-deposited sediment above the Younger Dryas boundary layer. The final study presents new evidence of a direct connection between cosmic impacts, environmental shifts, and major changes in human societies. Our investigation reveals slow changes in site utilization by humans for centuries up until and just after the Younger Dryas onset, the authors write, punctuated by significant abrupt change immediately at the Younger Dryas onset. The team proposed that changes came from a disintegrated large comet about 100 kilometers wide. This event likely set off major climate change in the northern hemisphere. There was a change from more humid conditions that were forested and with diverse sources of food for hunter-gatherers to drier, cooler conditions when they could no longer subsist only as hunter-gatherers, Kenneth said. The villagers started to cultivate barley, wheat, and legumes. This is what the evidence clearly shows. There's no doubt that something completely transformed the way people in Abu Huraira lived. This change was a vital initial step in transition from exclusive hunter-gathering to sustained agriculture and herding, the authors conclude. And the study has been published in Open Science, Airburst and Cratering Impacts. And this is on Science Alert by Rebecca Dyer. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.